All right. So we have some kids missing, and I believe primarily because some of you have Christmas gathering at home with family members and some friends and families who are visiting you guys. So we'll get started. Okay. So did anybody get a chance to see what we want to learn today? So let me do a quick roll call to see who all are here one more time. So we have Arya, Aryan, Dave, Chris, Neil, Rehan, Sarah, Sivatsav and Vihan. Alright. So let's get started. So yeah, anybody got a chance to see what we're going to cover today?
Yes, sir.
Okay. So before we start, a quick question to everybody. How was the experience with the test? Very honest feedback. I mean, there's nothing, no score, nothing going to anybody. So Arya said it was a good experience. Rehan said it's a good experience. Okay. See, I'll tell you, the purpose of the test was to do more of a, what you call, an assessment of knowing where we are, what we have learned well versus where we have opportunity to learn things better. So as I always keep saying that the syllabus for SAT is like those 13 units that we have to cover. So we have covered many of those and most of those I would say. So we are starting the second iteration of our what we have learned with respect to hello. You are Anshu. It's for yourself. I think your mommy was also supposed to be in the class to see what we are learning. Okay, it's okay, it's fine. Okay, so good. We have a few new students also in the class. So we have Vihan and we have Anshu. That's how you go. And everybody's okay, not cold, right? Okay. So this is a SAT class where those 13 units that we have in Khan Academy, we have covered one iteration of that and we are starting the second iteration from today. So for Vihan and Anshu, you are on time for this class to start. Okay. So today we will start with the topic which is dealing with, I mean at a high level you can say algebra 2 essentially. So we'll start with a system of linear equations and then we'll go to quadratic equations and then we'll play around with that to understand what we know versus what we need to know. Okay? Anything that you have in mind before we start or you would want to observe? Hello ma'am. Find a place for yourself. You can pick a chair and experience good or bad things that we do in the class. Alright. So system of linear equations that we talk about. That's what we are starting with. So many of you have already attended that class, so you would know what a linear equation means. But again, just a question. In layman's term, why do you call something as a linear equation? What does it mean? An equation. So linear equation. Again, some of the kids will get bored because they have heard me explaining this before. And linear equation, as we call it, this is a spelling. It draws a line.
Is that a constant rate?
I'm sorry?
Is it like that it grows at a constant rate?
Yeah. So an equation that helps you draw a straight line, which is a representation of a line. That's why it's called linear equation. Okay. So now let's look at what do we mean by that. So any equation I will call as a linear equation if I have something like this. And this is not the only form of a linear equation. What you have to look at is the power. The maximum power to the variable is 1. And that's the reason it helps you draw a straight line. And we'll see some examples of that as well. And guys, when I am going very fast, I'm making things complicated or confusing for you, don't hesitate to stop me. Okay? So any equation which has two variables x and y, and the maximum power to the variable is 1, that's a classic example of a linear equation. Okay? Okay. So now let's see how and why I'm saying that this draws a line. I'm assuming everybody is comfortable with the coordinate planes. Yep, x and y axis. This is x axis, this is y axis. Minus y, sorry, this is minus x side, this is plus x side, and this is minus y side. And again, in the simplified form, if you look at it, these are two number lines perpendicular to each other. That's what makes your coordinate plane. Yeah. Now, I said any equation, I'll not repeat the same equation. Let me say x minus 2y equal to 7. I'm saying this is a linear equation because the power to the variable, both the variable is 1. Okay. Now, let's look at it. So when again a repeat of what I said, what I've said before, when you have an equation, this is nothing but an agreement between the variables. X and Y have agreed, saying, okay, this is the relationship that we are going to carry. Meaning, for every value of X, Y will adjust in a way that these two things will result into this. So any equation that you look at, be it a linear equation, be it a quadratic equation or a cubic equation, any form of equation, that's nothing but an agreement between the variables. So this is your agreement between, as far as this equation goes, this is the agreement that they have. Meaning, value of x and y will change itself depending on each other in a way that your outcome is 7. So now let's look at it. When I say x equals to 1, what will be the corresponding value of y? So when x is 1, it becomes 6, yeah, minus 3. You are right. So see, this is what happened. You said, okay, if I pick a value of x, something as 1, y will change in a way that total outcome is 7. Yeah. Now when x is 2, when x is 2, negative 3 half, 2 becomes 5, 5 by 2, minus 5 by 2. Yeah. Let's say when x is 0, this is yeah. So see, this is as per this agreement, as per this equation, as per this plan that they have. These are the possible values that you will get. For every x, value of x equals to 1, y will be minus 3. For x equals to 2, y will be equal to minus 5 by 2. When x is 0, and you can simply go on. I mean, if I had a much bigger board, I would have probably made this table much bigger. I would have put x equals to 5, what is the value of y, x equals to minus 10, what is the value of y, and so on and so forth. Now, let's use this information to see what happens. So, this is, let's say 1, this is 2, this is 3, this is 4, minus 1, minus 2, minus 3, let it be, and minus 4 also. 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. And again, don't laugh at my drawing skills. I have just tried to plot it in a way that you guys can make some sense out of it. Yeah. Now, when x is 1, y is minus 3. So when x is 1, y is minus 3. So we are essentially talking about this point. Yeah. I have just found the first point when x is 1, y is minus 3. And everybody on the screen, you guys able to follow me okay, right?
Yes, sir.
Vihan, you're okay?
Yeah.
So see, this is the problem with this class, okay? When somebody new joins, I keep buzzing them more often just to make sure that they're able to catch up with my way of speaking and they're able to follow what we are doing on the screen. Everybody else who has been with me for some time, they kind of have gotten used to the good or bad habit, okay? Alright, now when x is 2, y is minus 5 by 2. So little less than 3, more than minus 2. Or less than minus 2 and greater than minus 3, whatever you call it. So when x is 2, we're talking about this line and this point will be somewhere here. Yeah. When x is 0, y is minus 7 by 2. When x is 0, it will be essentially on this y axis. Y is minus 7 by 2, which is 3.5, so somewhere here. if I join these 3 points, this plots a line for us. And that's why it is termed as a linear equation. So when I said that if I had more space, I would have made this table bigger with much more values. So these are the values essentially we are talking about. Everybody with me? Dave, Chris, Rehan?
Yes, sir.
Okay. Okay.
Yes, sir.
I know it's a post-lunch session. Some of you might feel sleepy, so it's my job to keep you guys awake. So any linear equation you pick up, be it, let's say, even if I say 7x minus 2y equal to 15, that's a separate contract. This is a separate contract, this is a separate contract. Yeah? And based on this thing, again, you will do the same thing. You will put a table and you will draw it, and you will see that you can play with this as much as you can if you want to prove me wrong as a teacher, right? You said that, I said that, okay, if I have an equation with two variables and the maximum power to the variable is 1, that draws a straight line. If you guys get an opportunity to prove me wrong, that you have an equation with two variables where the maximum power is 1 and that still doesn't draw a line for you, that is the situation I would want to come across. I've not come across that till date with so much of grey hair, but let's see if we have a chance. Okay? Alright? Everybody with me? Don't agree to what I say. Make sure that you get your hands dirty. Play with few graphs. Just make out some equations with power 1 and see if any of the equation draws something which is not a straight line. If you are not able to prove me wrong, then you'll have to stick to or agree to what I said, that if I have an equation with two variables and the maximum power to the variable is 1, it will draw a straight line. That's written in stone till you guys prove me wrong. Okay? An honest question to you all. Do you guys practice what we learn in the class? If you don't, I would say start doing it, because I had made some observation based on the test that we had last Sunday. A clear observation from my side was that you guys know the concept. A lot of things you know by yourself. Some of the things I have made an attempt to teach you guys. But then I found some of you were going wrong. It was not because you don't know, it's because you have not practiced enough. Math is all about practice, okay? So this part is clear, linear equation. So when we talk about linear equation, this is what it is. A linear equation gives you a possible combination of value of x and y, and that is indefinite, okay? If you just have one equation, you're dealing with one equation, you can get hundreds, thousands, millions of solution or combination of x and y value, okay? There's no one solution. If you're dealing with one equation, you're talking about as many number of solutions that you can think of. Now, life becomes a little more interesting when you deal with a system of equations. So when you deal with system equations, meaning when you have more than one equation, let's say you have 2y always. Let's say I have an equation called 7x minus 13y equal to 15. If I say find out the value of x and y, you will say that I cannot. I can find you all possible values, but there is no one answer to this. Okay? When I say now I'm giving you one more equation, then there's a possibility that you might get one solution, meaning you can probably find what is the exact value of x and what is the exact value of y. So the interpretation that we can draw or derive from this is, if you have two variables and you have to find out the value of two variables, you need at least two equations. If you have, let's say, an equation like 2x plus 3y minus z equals 15. Here you're talking about three variables, 1, 2 and 3. So if you have to find out exact value of x or y or z, you need as many number of equations. So you would need at least, if I tell you that, okay, I've given you two equations, find out the value of x, y and z. You'll say no, I need one more. Because there are three variables, I need three equations. That will be your starting point. You cannot find the value of three variables with two equations. No matter how influential, how convincing, how forceful I am. Okay? You need as many equations as the number of variables. Anybody wants to disagree? Try disagreeing, it's okay. No, so when I ask for it, right? I mean, I'm just forcing you guys to think. Okay? Think and tell me whether, have you come across a situation where you were able to solve or find out the value of three variables with just one equation or just two equations? Probably not. You'll not be able to. Okay? So that's the thumb rule. So now, I'm saying that I have two equations. I'm saying find out the value of x and y. I hope you guys don't mind if I take 15 seconds just to get my water bottle. But just first we'll start 5. Alright, so now we have two equations, and since you guys believed me that I have two equations and two variables, we can find out one solution for x and y. There are two ways you can do it. Does anybody remember what are those two ways?
First, you could do where you take the second one and then subtract 3y, so you get x equals to 11 minus 3y, and then substitute that for what x equals in the first one, and then find out for y, and then you plug in the value of y into one of the equations and find out for x.
That's called the method of substitution. Okay. What else?
Elimination.
Elimination.
Graphing.
Yes, Neil.
There's graphing also.
Exactly. So there, when I said two ways, I essentially said two high-level ways. One is you can do it by graph, or you can do it algebraically. Within algebraic method itself, you have two more ways. One is a method of substitution, one is method of elimination. Yeah? So now, again, don't have to memorize it. I have two equations. One thing that we started with was say that if I have a linear equation, if I plot it on a coordinate plane, it draws a line. Yeah? I have two equations. So this is one equation, meaning one contract between x and y, which let's say plot this line. I have second equation, which is another contract between x and y, which let's say plots another line. It meets here. And the point where it meets, if you find out the x and y coordinate of that point, that will be your solution to x and y. You all remember? Dave, Rehan, Vihan. So Vihan, are you able to follow this one, or this sounds new?
No, yeah, I think I remember this from Algebra 1.
Alright. So basically, it's very simple. Regardless of when you have learned this. One simple thing is, if you have a linear equation, that draws a straight line for you. When you have two linear equations, that draws two lines for you. Now, there are three situations that you can come across. If you have two equations, we are just keeping aside the algebra part of it. You're just solving it using the graph. If you have two equations, one situation is when they will meet. They will cross, intersect each other. Second situation is when they are parallel to each other, meaning they will not meet. In that case, will you have a solution? You will not. Because there is no one point. See, when I made a point saying that no, any equation is a contract between x and y, meaning any point on this line will satisfy this condition. Any point on this line
will satisfy this condition. Now, this is a point where it is intersecting, meaning this point is lying on this line as well as this line. Okay? That means this point is abiding by this contract and this contract as well. That is what becomes your point of intersection or a common solution for both the linear equations. Conceptually, if you relate it. Yeah? See what's up? Are you with me? Okay. So I'll keep on asking just to make sure that if you have any small or smallest of doubt in your mind, at least you are able to recall. So, same point, linear equation draws a line and every point on the line abides by this contract. This linear equation draws a line. I'm not saying this is the correct line, I'm just making it up. But every point on this line abides by this contract. So the point where it intersects or meets, that is a point which is common on both the lines. That's how it becomes a solution from this equation, graphically if you look at it. Yeah. So I said there is one situation when they will intersect. That is when you have a solution for x and y. There is another situation when the lines are parallel. There is not even a single solution, meaning there is not even a point which agrees to both the contracts. That's a parallel line. And the third situation is when it overlays each other or both the lines coincide. Now, the $1 million question is, how do you find when both the equations will intersect or be parallel or be coinciding without solving for it? There is a method for doing it. Who all remembers? Or who all has heard me talk about it before? Yep.
It was using the ratios of certain values and related values.
Okay. Any thoughts? Okay. No, that's okay. I'm just checking. From where I have to start. That's why I'm checking. Okay. Anybody on the screen?
I've learned this earlier.
I learned it 32 years ago. Tell me if you remember. Okay, so let's go back to this. That's fine. I was all the jokes aside, but the reason was I was just trying to recall or understand from where you would want me to start. Okay. So now let's say this is my one equation. Not 2y this time. Okay. 4y equal to 8. This is one equation. Okay. Now, if you guys remember, there is a standard form for any linear equation that you can relate to. And that standard form of linear equation is ax plus by plus c equals 0. This is called the standard form. So that you can relate every equation. So when you say this is a linear equation, if this relates to this standard form, then only this qualifies for being called a linear equation. Okay. Now look at this. Here, I'm just writing it just underneath this. Okay. Minus 8 equals to 0. So I just got everything on one side, so it becomes this equals 0. Now I have, this is my standard form and this is my current equation that I'm dealing with. Okay. Now look at this. What is the value of x? A, if I compare with the standard form? A is equal to 1. What is the value of b here? 4. What is the value of c here? Minus 8. Yeah. Everybody on the screen? Fine so far?
Yes, sir.
Okay. Now, all right. So, let's look at a situation. Let's use two equations. Just remember the standard form, ax plus by plus c equals 0. That's the standard form. Okay. So when you're talking about, let's say, quadratic equation, which we'll learn a little later, that also has similar form. Okay, where the maximum power to the x is 2, the coefficient of x square is a, coefficient of x is b, and the constant is c. Okay, but anyways, don't jump to this one. Quadratic equation is something that we'll learn down the line. Let's not worry about it for now. So when we talk about, let's say I have two equations, x plus 2y minus 8 equals 0, and my second equation is x plus 2y minus 4 equals 0. Or, okay, yeah, or let me put even smaller numbers, so that way my graph becomes much more clear. Okay, so between these two equations, if you see, the only thing that is different is this one. Okay, let's see what it means to us mathematically. So here my standard form is ax plus by plus c. Okay, so I will call this a a1. I mean, this is my equation 1, this is my equation 2. So this one I will say a1 equals 1, b1 equals 2, and c1 equals minus 3. For this guy I will say b2, sorry, a2 equals 1, b2 equals 2, and c2 equals minus 3. But no point complicating this, right? We'll stick to what we started with. So we will use let me not make it look clumsy here for a little bit. Okay, let's not even put this one for now. Okay, and for Anshu and for Vihan, if you guys are busy taking notes, don't worry about it. Everything is getting recorded. So me and the board is getting recorded. You guys are not. So this video goes on to YouTube, not because I have any intent of becoming a YouTuber in near future. It's primarily for you guys. So that no, you can focus on understanding the concept rather than being busy taking notes. Okay. So Pranay, that holds true for you as well. Now, yep, Vihan.
What's your channel? What YouTube?
So I'll send basically when I upload the video, I send the link of the video, so you can find from there. So once you guys get the link of the first video, I mean, since this is your first class, when you click on the link, you can subscribe it. I'll probably have 1133 subscribers when one of you join. Okay, so that's the number of subscribers I have, but that's not very important for me. I don't really care about it. So now, this is the first equation. Let's deal with this guy first. Again, same old stuff, nothing fancy. Let's look at what are the x and y combinations we're talking about. So when, let's say x is 0, we know that these are drawing straight line for us. Okay, so what do you need for drawing a straight line? Just 2 points. Yeah, just 2 points. So we'll keep a simple table. When x is 0, what is the value of y? 3 by 2. When x is 1, what is the value of y? 1. Yeah. Now, look at this equation and put similar table. Let's see what happens. X and y. When x is 1 here, when x is 1, it becomes half. When x is 0, 1. Okay, let's see what is happening here. 1, 2. See how tirelessly I am drawing graphs, right? I want you guys to have similar approach towards playing with maths. Whenever you come across a math, draw it, do it. Don't get tired, okay? Because that is when you will get the confidence and it will become more like a muscle memory for you. Okay? Now here, when x is 0, y is 3 by 2. So when x is 0, y 3 by 2. It is somewhere here. When x is 1, y is 1. X is 1, y is 1. And again, don't rely on my drawing skills, okay? So this is first line. Okay, this is the line. If I call this as 1, this is my line number 1. Now second one. When x is 1, y is half. When x is 1, y is half. Maybe here. When x is 0, y is 1. When x is 0, y is 1. If I would have done this in an authentic graph paper, this would have looked much more convincing, but this is a parallel line. Now, take this information. So everybody on the screen, you guys see it, right? If it doesn't look like a parallel line, you still got to believe me, this is a parallel line. And when you use similar equation and draw it on a piece of paper, on a graph paper, then you'll actually see it, converting into parallel lines, pair of parallel lines. Now let's look at this. What is happening here? Between these two equations, I purposefully kept the x and y coefficient of x and y same. I only change the c. That gives me a parallel line. So now, if you call this a1, b1, c1, a2, b2, c2, what you can interpret from this is, if a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, you are essentially talking about a pair of parallel lines. Yeah? Now, is this part understandable so far? Is everybody with me? Neil, Sarah, Sivatsav, Vihan?
Yeah.
Yeah? Makes sense? So, summary of what we have seen so far is that if I have two equations, two linear equations, where the coefficient of x and y are matching, meaning a1 and a2, b1 and b2 are matching, or a1 by a2, meaning the ratio of a1 by a2 and b1 by b2 is matching. Okay, it might so happen that this is 2x and this is 4y. That part is also fine. We are only concerned about the ratio, not the absolute value. Okay, so if the ratio of a1 a2, b1 b2 is matching and c1 c2 is not, that is when you can safely say that these are pair of parallel lines. Okay, can I assume everybody with me?
Yes, sir.
Wonderful. Now, let's play a little bit more. So, when the two linear equations are parallel to each other, meaning the ratio of a1, a2, b1, b2 are same and c1, c2 not, that's a pair of parallel line. And essentially, this distance that you see between c and c2, that will be the distance between the two parallel lines. Okay, play with that, get your hands dirty, and you would probably end up agreeing to what I'm saying right now. Now, let's look at another situation where we are talking about. So, Arya, this part is clear so far? Now you recall what you learned before?
Yes, sir.
Okay, alright. Now, let's look at an equation like x plus 2y plus 2 equals 0 and 2x plus 4y plus 4 equals 0. a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Let's see what happens in this case. Same thing, no fancy stuff, just put a table and we just need 2 points. Okay, so now I'm feeling a little lazy, I will not make the bigger table, and same thing for this guy also, let's put a table. Just 2 points. So when here x is 0, what is the value of y? Anybody? Mm-hmm. When x is equal to 1, what is the value of y? No. Oh, okay, yeah, my bad. Yeah. Now, how about this one? Let's look at this equation now. When x equals 0, what is the value of y? When x equals to 1. I'm just picking the easy numbers, okay, so that. So you are getting some clue already, okay? But let's not worry about it. And let's do a boring exercise one more time. When x is 0, minus 1. Okay, when x is 0, minus 1. So we are talking about this point. When x is 1, minus 3 by 2. So we are talking about 1 minus 3 by 2. This one. Now look at this guy. Same thing, 0 minus 1. Same point. 1 minus 3 by 2. Second point. It will draw the same line. So it is coinciding. Now, so mathematically, what you will say is this. If between these two, now you see a1 by a2 is equal to 1 by 2, b1 by b2 is equal to 2 by 4, which translates to 1 by 2, c1 by c2 is 2 by 4, which translates to 1 by 2. So essentially, you are saying that a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Yeah? So now, from this, you can interpret that, okay, when I have these two ratios being same and this being different, these were parallel lines. When all the ratios are same, they are coinciding. So this is the second situation we are talking about. When the lines are parallel, you have no solution. There is no one common point where both the lines are meeting. Yeah? So that means you will not have a solution for x and y. You will not be able to solve it. As soon as you get the value of a1 by a2, b1 by b2 same and c1 by c2 being different, that means the two lines are not going to meet. They are going to remain parallel and you will not have one common solution for x and y. When you have a1 by a2, b1 by b2 and c1 by c2 same, that means the lines are coinciding. How many solutions you can have? Infinite. Yeah? That's the second interpretation. Any questions so far? Kids on the screen. Dave, Chris. Yep.
No question.
No questions? You guys are not asking questions. Not a good sign. So we looked at two things. Now we will talk like we have mastered this concept. So if I have any linear equation where the standard form is this, if I have two linear equations, there are two things that we know. When a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, we are essentially talking about pair of parallel lines. Parallel lines. Okay. When all the three ratios are same, then we are talking about coinciding lines. Yeah. Now what other option you are left with here? If you look at all permutation and combination of these ratios, you have one ratio not matching, other two matching. When all are matching, what is the third situation that you are left with? None are matching. This is the only option that you are left with when it comes to ratio of the coefficients. And this is when the lines are going to intersect. Yeah? So, just if you have two linear equations, okay, before you start putting your effort for solving it, first thing that you might want to look at is, let me quickly look at the ratios and derive some interpretation that, okay, is it actually worth spending the effort or not? If my ratios are going to be same, I'm talking about coinciding lines. So I will not have a clear solution for this one. I'll have n number of solutions that I can dream of. If these two ratios are matching and this one is not matching, then I'm talking about parallel lines. I will not have a solution. Even if I spend next 2 hours solving it, I will not have have one solution for x and y. The only point when I have all the three ratios being different, that is when it is worth spending the time to figure out what the solution would be. So, if solving two equations takes you 5 minutes, or let's say 3 minutes, finding this ratio will take you 20 or 30 or maybe 35 seconds. And that 35 seconds will tell you whether you actually want to spend time on this one, or you want to just derive a conclusion and say, hey, this is what it is. Yep. Pradeep, with me? Everybody on the screen with me?
Yes, sir.
Okay. Now let's look at some more. See, again, whatever we are learning here, this is all about how you interpret the information to make a conclusion, and then you decide how you want to approach it. Now let's look at this. Let's look at one situation where I talked about, let's say, 3x minus y equal to 12 and 6x minus 2y equal to 24. If I have these two equations to solve, we simply see the ratio between this and this is 3 by 6, 1 by 2, 1 by 2, 1 by 2. So these are coinciding lines. I will have infinite number of solutions, no point solving it. Or you can also look at, if I take 2 common out, so it becomes 3x minus y equal to 12. When you have two coinciding lines, what does it mean? In absolute terms, this is one line actually. So it's one line, as simple as that. So that is another thing that you might want to take away from this discussion is, if you have an equation, if you multiply that equation with something or divide that equation with something, it remains the same equation. So you can, based on your convenience, you can pick any equation and you can multiply or divide the equation by one number depending on how you want to play with it. Yeah? So if I say I have an equation like, so this equation is same as if I multiply this with okay. So basically what I'm trying to say here is, this is a classic example of coinciding line, coinciding pair of lines, and then coinciding line is nothing but, it's the same equation basically, same one line. So, yep.
Does that mean that they plot the same line?
Exactly.
Or with proportional?
No. So, when the ratios are in the same proportion, all the coefficient A, B and C are in the same proportion, it is plotting a coinciding line. Now, what does a coinciding line mean in practical terms? If I say, I have 3 coinciding lines, what do you see? One line. It's actually the same line. Yeah? I say, I have 50 coinciding lines. I'm just wasting everybody's time. What do you see? Just one line. Yeah? So, that is how this information of coinciding lines can be used for our manipulation of equations later on. Okay? If you have an equation, you can multiply or divide all the terms of the equation with one number depending on your convenience. And we'll essentially use that concept for solving the pair of linear equations algebraically. Yeah? Okay? So far, yeah, somebody saying something? So far, I have not even talked about algebra, even if I said this is algebra 2. We are still dealing with graph. Yeah? So now, when I have two equations, I can, as I said in the beginning, I can solve it using graph, or I can solve it using algebra. So far we have only dealt with the graph part of it. Algebra is what we'll get on to now. Is everybody with me so far before I move on?
Okay. So, a quick takeaway from what we have discussed so far is that, a summary of what we have discussed so far is, what is a linear equation? What is a system of linear equation? What do we mean by solving a linear equation? How do we plot it on a graph paper? And how do we use that information for finding a solution? And how the coefficient of the x and y helps you determine the nature or the relationship between the pair of lines that you're talking about. Okay? Now, let's talk about the algebra part of it. So when, as I said, if I have two equations, if I have two equations and two variables, I can still solve it. I said that we can solve it by using some method of substitution or elimination that we'll figure out. But we have two equations, two variables, we should be able to solve it. Unless there is anything conflicting with this based on what we saw before, right? The ratio. If the ratios are all matching, they are coinciding lines, we'll have infinite number of solutions. If only C1, C2 is not matching, everything else is matching, then there will be parallel lines, there will be no solution. But right now, so Mandeep, you have joined 10 minutes early. Otherwise, you will end up learning a system of linear equations in the 4th grade. Alright, so the going in position is, if I have two variables, I need two equations, I have it. I should be able to at least attempt it. Now, how to solve, whether we'll be able to solve it or not, that we'll figure out. So I just gave it two equations. Let me write it out. Let's say I have two equations. So before you attempt to solve it, since you have learned something or you have recalled something that you would want to see whether there is a motivation for solving it or not. My a1 by a2 is 1, b1 by b2 is minus 5 by 1, c1 by c2 is 6 by 1, meaning all the three ratios are different. They are going to intersect, no question about it. Meaning there will be a possible solution for x and y. Now let's try solving it. So this is where the method of substitution comes into play. Meaning you find out the value of one variable in terms of the other variable and substitute in the other equation and then you solve it. So here I will say x equals to 1 minus y. I am getting this value from this equation and I will use the value of this x into this equation, which becomes 1 minus y. This is my x minus 5y equals 6. So 1 minus y minus 5y equals 6. So 1 minus 6y equals 6. Minus 6y equals 5. Y equals minus 5 by 6. I was not trying to impress you guys by solving this problem. Okay, that was not the intent. What was the intent? Ultimately, by doing this, what we are trying to do is, we are trying to come to a point where I have one variable with one equation, in one equation. I am repeating myself. This equation had two variables, this equation had two variables. If I say x plus 5 equal to 18, can you find out the value of x here very easily without any problem? It's very easy, right? One variable, one equation, very simple. That is our desired state. By doing all that circus we are doing, right? Our objective is to come to a point where I am able to convert that into a form where I have one variable in our equation. And you will see the same thing when we do method of elimination also. Always remember, what is the goal? Our goal is to come to a point where I am able to form an equation by doing all possible manipulation to come to a situation where I have one equation with one variable. See here you have only one variable, y and y. That's it. Like I gave this example. If I have one equation with only one variable, it's very easy to find out the value of it. So by doing this method of substitution also, you are trying to mimic the same thing.
you got the value of x in terms of y, meaning x doesn't have its own existence now, it can be related to y. That you found from the first equation, and then you substituted this value in place of this x. Yeah? Not this one. Maybe I'll put this arrow like this. I put the value of x into this equation. So I substituted the value of x into the other equation, which helped me get to a situation where I have one variable with one equation to be able to solve. Okay? So, summary of this is, if we have to solve any equation, our ultimate state or desired state is where I have one equation with one variable, then I get the value of this variable, and then I can use this value in any of the equation to find out the other variable. So always look at what you want to do to eliminate one of the variables. So this is not a method of elimination, but this is a method of substitution where you're finding one variable in terms of other one and substituting that into the previous equation to convert into a form where you have one equation with one variable. That's the goal. Okay? Is it too loaded in information? Are you guys with me so far? I'm getting you guys tired.
I understand it, sir.
Understand? Tired also? No? Pranit, with me? So, it's almost time. So I will not drag this further. Let me give you a summary of what we have learned today so far, so that we go out of this class with a takeaway, and we'll use that concept when we come back to this again tomorrow, when we'll talk about method of elimination, and then we'll see if we can do some practice. I will bother you guys to do some problems in the class, and that will be only with the intent to make sure that you guys are able to conceptually relate and apply it in the while you are doing it. Okay. So for the new kids in the class, you guys, I call you guys kids. Okay. I have a daughter who's ready to go to college next year. So I mean, I started teaching her first before I got excited to think that I'm still relevant when it comes to maths. So that is how I started. So don't get offended if I call you guys kids. Okay. Now, what we have learned today, couple of things. Linear equation is an equation that draws a straight line in a coordinate plane. Okay. And the maximum power to the variable is 1. That's the first takeaway. Second thing is, you can solve a pair of linear equation in two ways. One is in the form of using graph or doing algebraically. Using graph is simple. You have a linear equation that draws a line, draw a line. You have two linear equations, draw two lines, and then they can either intersect, they can be parallel, or they might coincide with each other. And that is where we saw how do we relate the ratios or the proportion that helps us determine whether they'll be coinciding, be parallel, or intersecting each other. Okay, that's the second thing. Third thing that we learned was, we started with the algebra part of it, where we learned about the method of substitution, where our ultimate goal is to convert the two equations or manipulate the two equations to get to a point where I have one equation with one variable, so that we can get the value of this one. And then once you have it, plug it into one of the equations, and then you'll get the answer for it. So this is the concept part of it. We'll get our hands dirty a little bit more tomorrow with the method of substitution, and then we'll also learn method of elimination before we get our journey started with the quadratic equations. Any questions?
No, sir.
No questions. Aryan, Rehan, Dave,
No,
Chris.
no, sir.
Okay. Srivatsav,
No, sir.
Praneet, Anshu. Everybody okay? You guys are making me jobless then. Alright. Enjoy the rest of your evening. We'll meet again tomorrow, same time, and we'll see what else we can learn, and be ready to practice, okay? I mean, because my only request to you guys would be, whatever we learn, that'll be of no use if you're not able to practice. Okay? Alright? I'll let you guys go. Enjoy the rest of your evening. And just for information for you all, I'll be taking classes tomorrow and next Saturday, and then I'll disappear starting the Sunday, which is 22nd. So I'll be gone for 2 weeks.
I'll be back on 2nd January. So you guys will have 3 days of off. And I'm pretty sure most of you will be traveling or having some plans to enjoy Christmas. But we'll get our journey started from 2nd. But from today, tomorrow and next Saturday, we'll have class. Alright? Yeah, Chris.
Sir, I just had a question. The SAT practice paper we took, will we get to know the score?
No, so I'm not scoring or not grading anybody, okay? The purpose of the test is always going to remain an assessment of myself, where I want to make sure that whatever I'm teaching you guys, are you able to understand and apply, right? When anybody in the class doesn't do good, that's a reflection of my teaching skills. So I'm always trying to get that insight so that I can try teaching those things to you guys in a much more simpler, easier, understandable way. So that's the purpose. I'm not going to grade, I'm not going to give any score, because my only objective is to make sure that you guys keep learning math and keep enjoying it, okay? If I start sharing score, that will go in a different direction, which is not the intent here. Yeah? So basically, I went through each and every question paper, every solution. Couple of feedback that I have is, I see everybody is tempted to just put the answers. I would be more happy if I see you guys putting some scratch work next to the question also. So that way I can see what is the approach you have taken for solving it. Okay? So that will be the only feedback that I have for you guys. But nobody will get a score. If somebody is so very keen on getting the score, let me know one-on-one. I'll figure out what to do. Yep. Alright, I'll let all the senior kids go, because the junior kids are about to start.
Bye.